Okay, hi. So today we're going to be doing the beginning of rates of change and tangent lines. You're going to see that this is going to repeat into your derivative chapter. So this is going to be the fundamental of calculus and derivatives. Okay, so let's talk about average rate of change. So average rate of change, you've heard rate of change before. Another name for rate of change is the slope. Okay, so as of this point, you have been only able to find the slope of a linear line. You've never been able to find the slope of a curve. Well, this is how you find the slope of a curve. So the average rate of change, another way to use it is going to be the secant to a curve. And the secant line of a curve is just a line passing through 2 points on a curve. So let this point be, so let this value be A and this value be B. Okay, so I'm making a point from A, f of A, to B, f of B. Okay, slope of the secant line is going to be the average rate of change over a closed interval A to B. And this is what you get. So it's going to be the m of the secant line, or the slope of the secant line, which equals the slope between the points P and Q, is going to be equal to change in y over change in x. Remember, y equals f of x, and that's going to be f of b minus f of a over b minus a. It's the same thing as saying y2 minus y1 over x2 minus x1. It's just you're getting into advanced math, so they want you to be able to do it like this. And it'd be helpful for you to already understand this. So let's find the average rate of change of these 2 points here. So I'm going to name this point. So A is usually the most left point. B is going to be the right point. So this is going to be A, f of A. This is going to be B, f of B. So I just plug into the formula. So the slope of the secant line is going to be 15 minus 10 over 7 minus 3. So that's going to be 5 over 4. That is the slope of the secant line between P and Q. Now let's try this one. So this one's a little different because we didn't need to do any evaluating in this one. We already had our y values. Well, here to find our y values, we need to plug A and B in here to find our f of B and f of A. So this is A, and that's B. So let's do our formula. So we have the slope of the secant line, or the average rate of change, is going to be f of b, so f of 12 minus f of 10 over 12 minus 10. So remember f of 12, so where I see x in here, I'm going to put 12. And then I'm going to subtract it, and then I'm going to put where I see x in here, I'm going to put 10. So that's going to be 4 times 12 plus 1. Okay, so that's f of 12. Now minus f of 10 over 12 minus 10 is 2. So that's going to be 48 plus 1, which is square root of 49 minus square root of 41 over 2. So your final answer is going to be 7 minus the square root of 41 over 2. That is your slope. Let's not use decimals when we don't have to. Okay. So same thing here, it's just logarithms. So I'm probably going to go a little bit further than your book does, but if you can go the distance I'm going, you'll also know the answers beforehand. So the average rate of change of here is going to be f of 4 minus f of 1 over 4 minus 1, which is going to be ln of 4 minus ln of 1 over 3. ln of 1 equals 0. So you have ln of 4 over 3. Your book will probably be okay with this, but I'm just going to go a step further. So another way to write that is 1/3 ln of 4. And calculus is going to do this to you. It's just going to be like, oh, hey, remember this logarithm? So this is the power rule of a logarithm, so all you're going to do is just take this and then just make it an exponent of that, which is going to be ln of 4 to the 1/3. And if you want to go even further, that can be ln of the cube root of 4. Your book will probably be okay with this, but if you can do this step, you can do all of those. Alrighty. Okay, so next we're going to be talking about tangent to a curve. So the tangent line of a curve, this is a line that's going to intersect a curve at one point. So far in all your journey, you have not been able to find the slope of a curve at a point. You've only been able to, well now, since what you just learned, you've only been able to find it like using a secant to a curve. Well, now you can find it at a point. And you can do this by a few assumptions. So the slope of a tangent line is the same thing as the instantaneous rate of change at a point x equals a. Now, this could be x, it could be t, it could be whatever you want, okay? The formula to the slope of the tangent line is essentially the same as finding the slope of the secant line. Following will list some differences, and I'll show you why. So here's the secant line. So we have f of b minus f of a over b minus a. Okay? So h is going to be b minus a. So that's the distance between a and b. So this is subtracting. The only thing when you get here is h is going to be so close to 0 that you don't need to do anything. So h is going to become b minus a. Okay? Now you see this a plus h. So here your calculus book is going to have a and a plus h. Well, let b be that a plus h, okay? Because it's still this point and then this point. So b, this is going to turn to a plus h. And the reason why they do this, you're just simplifying right there. So to further it, we're almost done. So h is going to be so close to 0, it's going to be like 0.00000000001. Because it's a and a plus h keep getting closer, see, h is getting smaller. So you'll just make that the limit as h approaches 0. Okay? And that's how you get the instantaneous rate of change out of x. So as we calculate the average rate of change at smaller and smaller intervals h, we approach the slope of the tangent line. Point P is a clear example of the tangent line to a curve. Okay, so I'm going to get here. So here's our point, and our tangent line just kind of glides right off the point, like that. Okay, so let's find the point of the curve for this function. So we have m equals the limit as h approaches 0 of f, so x equals a, so that's going to be f of a plus h minus f of a. Oh, you can't see anything I'm writing. Sorry. F of a over h. Now, most students get confused here. This is just like a composite function, okay? So let me put this function over here. So let's do f of x equals 9 minus x squared. Okay? I know you all would know how to do f of 2. So f of 2 would be 9 minus 2 squared, which would be 5. Okay? So let's add more. Let's do f of a. So that's going to be 9 minus a squared. Okay? Now let's try f of a plus h. So where you see x, you're going to put a plus h. So that's going to be 9 minus a plus h squared. So whatever is here, you're just dropping it in for your x value. Okay? So let's go ahead and get started. So where I see x in here, I'm going to put a plus h. Always put your limit at every step until you're evaluating that 0. Now you can't evaluate right now because if you put 0 in here, you're going to get 0 on the bottom, which you'll have everything wrong. So f of a plus h, so I'm going to have 9 minus x. There's x, I'm just going to put a parenthesis here. And I'm just at this part of the equation. So where I see x, I'm going to put a plus h. So 9 minus a plus h squared. Okay, now I'm on the minus. Make sure you put parentheses here. F of a. So where I see x, I'm going to put a. So that's going to be 9 minus a squared. Okay. And now I'm going to FOIL this. This is a plus h times a plus h. So it's going to be 9 minus, I'll just show it in this one, a plus h times a plus h minus 9 plus a squared. Okay, I'm going to FOIL that. It's a perfect square, so you could also just use the perfect squared trinomial formula. Oops. So you're going to have a squared plus 2ah plus h squared minus 9 plus a squared over h. Distribute the negative. So this is what calculus is. It's just a little bit of calculus, and most of it is, it's algebra with the cherry on top is what mostly it is. So you gotta, if you like algebra, you're gonna do fine in this course, so please don't get discouraged. Okay, so equals a limit as h approaches 0 of 9 minus a squared minus 2ah minus h squared minus 9 plus a squared over h. So this is the fun part. It looks scary, but it's really not, because a lot of the stuff cancels out. So you have 9 minus 9, that's gone. Negative a squared plus a squared, that's gone. So you're left with a limit as h approaches 0 of negative 2ah minus h squared over h. Almost there. See something? Yep, that's the greatest common factor right there. Greatest common factor, that h goes away, and then you can evaluate. Hooray! So then you got limit as h approaches 0 of h times negative 2a minus h over h. That's gone. So you have the limit as h approaches 0 of negative 2a minus h. Evaluate the 0, so you get negative 2a minus 0, which is negative 2a. That's your slope at x equals a. Okay. All right, let's do another example. Okay, so same thing. So slope is going to be the limit as h approaches 0 of f of a plus h. So x equals a, so that's why I'm putting a there, minus f of a over h. So remember, so just this part here where I see x here, I'm going to put a plus h. So I'm going to have the limit as h approaches 0 of 2 over x, which is a plus h, minus f of a, so that's going to be 2 over a over h. So this is a complex fraction. You could find the least common multiple, subtract, divide, multiply by the reciprocal, but what's going to happen, the least common multiple is going to cancel out. So this is how I do it. I just circle all the denominators, so this is my denominators in what I call the main numerator. I just have a 1 in this one, so that's it. So my least common multiple is going to be 1 times a plus h. Don't worry about the 1, so my least common multiple is actually a times a plus h. And I'm going to multiply every term by a times a plus h. And you'll see why shortly. Okay, your denominators cancel out, so that's gone. That's gone. Uh, 2a minus 2 times a plus h. So then you're going to have the limit as h approaches 0 of 2a minus 2a plus h over h. which I think I made a mistake somewhere. 2A. Oh, I forgot to distribute the 2. Here you go. There you go, and then that's supposed to be a negative. All right, down here. Equals a limit as h approaches 0 of 2a minus 2a minus 2h over h. So you're going to have the limit as h approaches 0 of negative 2h. Oh, and I forgot to keep with the a times. Don't forget that part. That part's important. Yep.
What are you still here? I'm sorry. Okay, I was turning off the lights, but that's fine. I usually turn everything off back here when I go to the other part of the building, so you can get them when you're done.
Okay. So here you can go ahead and cancel out the h's right here. And then you do the limit as h approaches 0 of negative 2 over a times a plus h. Okay, now go ahead and evaluate 0. So you get the limit as h approaches 0 of negative 2 over a squared plus AH, which you end up getting negative 2 over a squared. Okay, and there you go. All right, have a good night or day, wherever.